And next up in our look at transformations of graphs, let's talk about x-axis reflections. So x-axis reflections, let's look at y equals negative x squared. So now I have a negative in front of the function. It's not a number being subtracted from it on the outside. It's not a number being subtracted from it on the inside. It's just a negative multiplying it. It's a negative out front. What that does to a graph is it reflects it about the x-axis, so it gives you the mirror image about the x-axis. So we still have our U-shape, but now it's going to be upside down. So x-axis reflection, a negative out front, just flips it upside down. If we were to look at negative x to the third, that's our snake graph, but flipped upside down. And let's see here, y equals negative absolute value of x. That is our V shape, but flipped upside down. And what's our other one? Y equals negative square root of x. That's still our shooting star, but now it's shooting down there instead of up. And let's see here, so those are the x-axis reflections. If you have a minus on the outside, if you're multiplying by -1 on the outside of the function, that is going to give you an x-axis reflection. Let's tack on y-axis reflection here as well. Y-axis reflections, the negative is going to be on the inside of the function multiplying the x, as opposed to multiplying the whole function. So for example, I'm going to look at the square root of negative x. So it's not a number being subtracted anywhere. It's the x on the inside of the function now being multiplied. So you can see above there, y equals negative x. When we did that x-axis reflection, that negative was on the outside of the square root. Now for the y-axis reflection, the negative is on the inside of the square root. That is going to reflect it left to right, right to left, or over the y-axis. So that is what a y-axis reflection looks like. And unfortunately, the square root is really the only interesting one. If you were to take x squared, if you're taking notes, you don't need to write this down. If you were to take x squared and reflect it about the y-axis, well, you just get the exact same thing. Well, that's not super interesting. If you were to take x to the third, the snake graph, and reflect it about the y-axis, well, you would end up getting this guy here. So left to right, right to left. The reason I'm saying that's not very interesting, well, that's exactly the same as the x-axis reflection for y equals negative x to the third. And the reason for this is, if you plug a negative x into the third power, that's the same as just having the negative on the outside. And negative cubed is negative. And then the last one there, the square root of x, also not super interesting. It's very similar to the U-shaped graph. If you reflect it left to right, right to left, you get the exact same function there. The reason for that, and for x squared, I can go back and do that. If you plug a negative x into the absolute value, well, the absolute value just gets rid of it. Same thing if you do it into the squared function. Negative x squared is positive x squared. So those guys are not super interesting when it comes to y-axis reflections. For now, in terms of the graphs that we're looking at in this section, only the square root is interesting with a y-axis reflection. They're all good for x-axis reflections. Flipping them upside down gets you a significantly different looking graph, but the y-axis reflection's not as interesting.